final haremos el Kahoot. Los tres que ganen, los tres primeros lugares, serán acreedores a este viaje a Las Vegas, ¿vale?
Yo nada más quisiera complementar de que si no se inscribieron, es importante, no por interés, solamente asistieron, que sí le puedan dar al final a Gaby su información para que también es parte del check, ¿no? Para poder ganar el requisito. Y dos, si se inscribieron con un correo no corporativo, mismo caso, pudieran pasar con Gaby a pasarles información para que pudiéramos tener ese correo corporativo también, ¿no? Son como las reglas básicas.
Bueno, y ahora sí, yo ya no le quito más tiempo a Lisa. Vamos a switchar a inglés. La presentación con Lisa es en inglés. Cualquier duda, de todas maneras, podemos parar la presentación. Si alguien tiene, necesita apoyo con el tema de algún término o algo, con mucho gusto. Nosotros estamos aquí para ayudarlos, ¿vale? Y bueno, pues les presento a Lisa. Lisa, la verdad, es una de las expertas. A mí me encanta la forma en la que habla. Lisa, I'm going to make the introduction to you and leave the session to you, obviously. And I'm just talking with a team and talking with a crowd that we have today, that you are one of our experts in zero trust matters, and I'm one of your biggest fans in terms of when you talk about zero trust, the way that you explain, the way that you develop the conversation, and obviously the experience that you have in the field. For everybody feel comfortable about what are your experience, what are your journey, and how is the way that the customer should be doing or applying the zero trust strategy into the companies. Okay.
Thank you.
So Lisa, welcome. Thank you so much for your time. And now we are going to be with you.
I appreciate that. I'm pleased to speak with you today. I'm excited about the topic of modernizing.
Hold on a little bit, Lisa, because we can hear you. Let me check just the audio. ¿Esta está conectada al audio?
Okay.
Lisa, can you try again, please?
Yes. Can you hear me now?
Yes.
Oh, good. Thank you. I'm very pleased to talk with you today, and I am very excited about the topic of zero trust. I have been working in this area for 20 years now. I have done standards work. I have done implementations at a previous employer, but I am focused now on helping to change the definition of zero trust. And to do that, we must understand where we come from. So we will start with some history and then talk about what zero trust means today. And then we will talk about how you can implement zero trust using this modern technology. So the initial phases of trust. 25 years ago, I worked for an insurance company, health insurance, and we had a very simple network. We had firewalls at the edge of the network. We had a VPN to bring users in for remote access. If you were inside of the firewall, we trusted you. If you were outside of the firewall, we did not trust you. I'm sure this sounds familiar. I think all of us started out with some variation of this model. So this was really not as simple as it looks, because we also had branch offices. We had partner companies that were connected in. We had some attempts to segment the network, maybe with VLANs, maybe with IP segments, but it was extremely limited in the capabilities. So this basic separation, for example, when I was at Blue Cross for the insurance, we had Wi-Fi. We introduced it for the first time, so you know that was a long time ago. And once we introduced Wi-Fi, now we had to worry about who got on it. So we made a Wi-Fi segment for guests and a Wi-Fi segment for employees. We could separate them, which is great. But if the guest walked in and plugged into the wall, they were on the employee network. We could differentiate on the Wi-Fi, but we could not differentiate on the wired network because it was older. We started to look at network access control, layer 2 port-based access control, 802.1x and radius. Again, This was easier on the Wi-Fi because these devices came with an 802.1x connection, but the older devices, the desktop PCs, maybe did not. So the goal was to lock down both our wireless networks and our wired networks so that only managed devices and authorized users could connect to those networks. The challenge was, could we? NAC was the initial attempt at this technology, and it did not go well. I was a NAC specialist. I started out with NetScreen Technologies. We got acquired by Juniper Networks. A decade later, we were spun off as Pulse Secure. So you may recognize those names. We had a VPN solution, we had a firewall solution, and we had a NAC solution. The challenge with NAC, what made it hard, was you had to lock down your entire network, all of your ports, before you could reduce your risk. But not all devices were capable of doing NAC. We had phones, we had printers, badge readers that needed to connect to the network. So we could not do port-based admission control. We tried to do MAC address admission control. That gets complicated. And we got to a point where there were too many pieces. You had 802.1x and MAC authentication and a MAC address database and behavioral profiling. If you tried to do this maybe 15 years ago, you remember all of these pieces. And it was many things that had to be coordinated, many opportunities for it to break. So we started to think, we also need to know more about the person and the device. What is my role? Not just am I an employee or not, but what kind of employee am I? Am I trusted? Am I untrusted? And the devices. When personal phones started to be smartphones, when personal laptops happened, now you have corporate managed devices and personal devices. We need a way to figure out how much trust to extend. So this is where identity starts to come in. But we weren't getting to true zero trust. The first step along this road was the Jericho Forum. The Jericho Forum had the concept of de-perimeterization. We are taking away the perimeter because securing the perimeter is not possible in a mobile world. So the Jericho Forum said, instead of securing the perimeter, we need to secure all of the devices. And the data that travels among these devices was a good idea because it recognized that the traditional perimeter security approach was no longer sufficient. Unfortunately, the problem is obvious. We went from having one perimeter, or maybe two or three if we had 2 or 3 data centers, to having hundreds of perimeters or thousands of perimeters. The perimeter did not go away, it just went everywhere. Every remote laptop, every phone, every device connected to the network. Again, this was too difficult for IT staff to manage. This is where Forrester comes in and introduces the concept of zero trust. So we've had a perimeter at the edge to your device is the perimeter. Well, now we're going back, but we're making the perimeter even smaller. We're saying we're going to put a perimeter around our data and our servers. So we don't trust anything outside that perimeter, and that includes our users. The users might be on the same network, or they might be remote, but we only trust the servers and the data. In order to give access we need to establish trust. The term zero trust is short for zero implied trust based on what network you are on. We no longer trust you if you're internal. We don't trust you on the network. We don't trust you off the network. We must establish trust no matter where you sit. We're starting to get into identity-aware access. So the core principles were authenticate the user, figure out what they are authorized to get access to, and limit them to only those things, and then provide access in a way that enforces those restrictions. So if I start off and I am an authorized user, I'm connecting from a corporate device, now I'm allowed to access my resource. But if I try to come in from a personal device, maybe I have only a little access or no access at all. This is where you started to look at identity. People said identity is the new perimeter. It's a good idea, but identity is not enough. It's context. Context includes identity. It includes device information. It includes compliance, whether I am running the right software. It could include some level of location, whether I am on the network or off the network. We want to authorize based on these principles of verify who the user is and what they need access to, limit them to only that access, and change the limit if their situation changes. Now, the original white paper was created around securing a network. Zero trust architecture was focused originally on that on-premise user connecting to a local resource. At the time, we wanted the same level of visibility and control for that local use case that we could get for a remote user. But here is the problem. That local use case was no longer the only thing we had to worry about. Users were becoming mobile more and more. And then the cloud came along and we started running our applications in the cloud. So now you've got users everywhere, on network, off network. And now we have applications in the data center. We started to have software as a service, SaaS apps, Office 365, Salesforce, Box. We had private data in public applications. And then cloud applications became more involved. Now you have private applications on a public provider. AWS, Azure, maybe clouds like SAP or Oracle, infrastructure as a service or platform as a service. So you have SaaS, IaaS, PaaS, and the data center. You have all these different types of applications. Google came along and started to build a real-world implementation of zero trust. Google called this Beyond Corp. They were moving beyond the corporate network. In 2009, they were targeted by nation-state attackers as part of Operation Aurora. They had intellectual property stolen. They needed better security. Their white paper, their first white paper, said almost every company today uses firewalls and perimeter security. But this model is flawed because if you breach that perimeter, the attacker has easy access to move laterally and access data. So Beyond Corp was the first big zero trust implementation. They considered both the internal and the external networks to be equally untrusted. They dynamically established authorization and provided access. This should be good news. Somebody has done it successfully in the real world. The problem is you had to be Google to accomplish this. They proved that you can do zero trust with network security controls, focused on the concept of network access. But Google is a company run by engineers for engineers. They have an effectively infinite budget, and it still took them 7 years and 6 white papers of design and deployment. Very few organizations have the resources or the time to do what Google did. So doesn't really help me at Blue Cross. Everything up until now has been about the perimeter. It's here, it's gone, it's smaller, but cloud and mobility have brought us to a point where there are more things outside the perimeter than inside. And through this evolution, we've kept building new capabilities on the perimeter model. But we reached a point where we realized we needed to scrap that model and start over. So this is where Gartner comes in. And it's another 5 years later. 2019, Gartner picks up this concept of zero trust, which was not really very used at that point. Gartner says, we're going to redefine zero trust with a series of white papers. The first white paper is very obscure. If you read this white paper, I am impressed because it did not get a lot of press. It did not do well, which is a shame because it was a good theory. Continuous, adaptive risk and threat assessment. Understand who is requesting access and grant access based on a dynamic assessment of their context. In the meantime, Forrester, that original zero trust white paper, they are trying to introduce it again. They are talking about a zero trust ecosystem. Gartner sees the term zero trust becoming popular again. And Gartner says, hey, zero trust is not where it's at. We want continuous adaptive risk and threat assessment. But Gartner loses that debate over what words to use. So zero trust was the word that caught on. And Gartner finally says, okay, we will talk about zero trust. But zero trust network access, we're still talking about the network, not the users and the applications. Gartner said, legacy perimeter security simply does not work, and it does not scale for the requirements of digital business and digital government. Okay, we've seen that for 10 years, but what does work? At the same time, about a year later, Gartner introduces the concept of SASE, the Secure Access Service Edge. Gartner concluded network connectivity and network security were really one problem space. It's really a powerful concept. You start forwarding your traffic and you add capabilities in the path. So you have better applications. You have a business imperative to be competitive. You need better security that is more elastic, that is less restrictive. IT security has always been considered a restriction, a limit on the business. We can't continue that way. Security must enable the business rather than inhibit the business. So Gartner says the way to do that is to shift the security processing to the cloud. We have a framework that is based in the cloud. We make secure connectivity. We move the burden of security into the cloud. And now you can have very simple end user components. You can push the security as close to the user as possible. You don't have to bring the user into the data center, go through a stack of appliances to go out, or bring the user into the data center and go through a stack of appliances to come in. We will put the cloud in between any user and any application. We will run all the services in the cloud, and that is the benefit of SASE. Smart cloud, simple edges. This may sound familiar because this was Zscaler's security model before Gartner even came up with a word for it. We handle over 200 billion transactions in our security cloud. We apply in line over 8 billion security updates to those transactions. We were uniquely prepared to deliver this SASE model, and Gartner recognized this. We were the only leader in the first SASE Magic Quadrant. In the meantime, the United States government starts to get involved. And the first place is the National Institute of Standards and Technology, or NIST. NIST publishes a document that defines a zero trust architecture. So this is NIST 800-207. This is the first white paper that shifts away from defining zero trust for the network. Now we're looking at a zero trust architecture that focuses on use cases, approaches, and threats. We are no longer trying to protect the network. We are now trying to protect the users, the applications, and the data. The network starts to become just transport. At the same time, our National Security Agency starts to talk about how to embrace zero trust. So NIST is talking about defining a zero trust architecture. NSA is talking about how to change the way that we think about zero trust. Zero trust is focused on resource protection and the idea that trust is never assumed or granted implicitly. Trust must be continuously evaluated. NIST currently has a National Cybersecurity Center of Excellence, and they are bringing together vendors to collaborate on real-world zero trust implementations. Zscaler is proud to be participating in that activity. The NIST Zero Trust Architecture. This is another one of these great diagrams that has policy engines and policy enforcement and policy administration, but it really breaks down very simply. The first piece is context. What can we use to establish trust? How do we determine who is allowed to access a resource? So when a user requests a resource, the first thing we do is terminate the connection. Unlike a local network where you plug in and you're on the network, you're connected, and then we decide where you can go. Unlike a VPN where you make a tunnel into the network, you're connected over the tunnel, we decide where you can go. The NIST architecture says terminate the request, inspect the traffic and the data, identify the requester, and determine where that traffic needs to go. So now we understand fully the request. The next step is verify whether we should allow it. Identify the user, identify the device, pull in other information about compliance or the sensitivity of the data or the threats in the environment. We bring together all of this context. That's how we make a policy decision. And only if all of the context is successful, then we make the connection. But we don't connect an endpoint to a network. We connect a user to a particular resource. very targeted. So this is not a local network where you're on the network. This is not even a virtual private network where you're remote, but you're making a connection to the network. This is micro segmentation between a user and an application. And again, it looks a lot like what Zscaler has already been doing with Zscaler private access. The challenging thing with SASE, going back to Gartner, was that it really combined two different areas of network and security. So Gartner then decides, okay, there's a good reason to think of them together, but there's also a good reason to think of them separately. The network piece is evolving slowly. It could be routers, it could be SD-WAN, it could be 5G. It will change over time. But security is more mature. It's more understood. So SASE is the general framework. The WAN edge is how you get to the thing. And the security service edge is the controls along the way. And Zscaler is also a leader in the Magic Quadrant for the security service edge. Zero Trust is a component of the security service edge, along with things like secure web gateway and firewalls and data protection. Finally, we had a big disruption in the United States. You may have heard about it. We had an oil refinery get hacked. Colonial Pipeline distributed gasoline, and they got ransomware. They shut down their pipeline. We had gas lines in the US. I was affected. This whole Southeast where I live was affected. At the same time, federal government agencies were also targeted with ransomware by nation-state attackers. So the federal government said, we are going to introduce a federal zero trust strategy. The federal government's approach to cybersecurity must rapidly evolve to keep pace with our adversaries. Moving towards zero trust is the road to get there. The neat thing is, this has a lot of the same technology references: enterprise identity, multi-factor authentication, access controls. But it's a major architectural shift for the federal government that's going to be a multi-year process. And it has deadlines. For the first time, agencies had deadlines, and some of them were short. So agencies must achieve zero trust by the end of fiscal year 2024. That sounds like a long way out, but for the federal government, that's light speed. Also, there are sub-deadlines. They had 60 days to submit a plan. They only had 30 days to designate a zero trust lead. So now, all of a sudden, we have deadlines. People must take action, but what can they do? This is where Zscaler comes in. The traditional approach to zero trust, that hub and spoke network, the complicated internal segmentation, the castle and moat security, that hard perimeter, all of that worked well when the data center was the center of everything. But it is not flexible, it is not resilient, and it is not scalable enough for today's world. First, the applications left the data center and moved to the cloud. Then we saw a network transformation as users also left the premises. So we're moving away from hub and spoke to a direct to internet, local breakout model. Maybe SD-WAN, maybe just direct connectivity. And this is driving a corresponding security transformation away from legacy network security models, away from perimeter firewalls and virtual private network or VPN. We are moving towards a cloud-delivered zero trust architecture. This is important because Zscaler's zero trust exchange allows you to do zero trust more easily. Instead of building stacks of appliances at the edge of your network, we run those functions in the Zscaler cloud. There are 3 revolutionary pieces of our model. The first revolution is when we think about making policy decisions and policy enforcement in line between the user and the app, we are not only looking at an external user coming to an internal resource. We are also looking at that external user going out to the internet. We must protect the user in the same way that we protect the resource. So when a user goes out to the internet, or even to software as a service and public hosts with private data, first we want to find out who is the user. Then we want to identify details about the device. Is it corporate or personal? Is it managed or unmanaged? Is it compliant or uncompliant? And there may be other context to consider. What is the risk? What is the sensitivity of the data? Where are they trying to go? We consider all of this context for an outbound packet, and we only connect the user if it is safe to do that. Nothing bad can come to that user, and nothing good can leak out. So we can do intrusion prevention, URL filtering, cloud-based firewalls, maybe even sandboxing of malicious traffic. We can protect against random ransomware. We can do data leak prevention or DLP. We can do CASB or Cloud Access Security Broker to ensure that users are only accessing authorized resources. The user is protected from the threats on the internet, and the private data in software as a service is protected as well. This was the foundation of zero trust at Zscaler. But we had to expand because we could not only handle outbound traffic. We also had to protect private traffic or inbound, what used to be inbound traffic. Now that data can be everywhere. So we take the same model. When a user requests an internal resource, a private resource, that might be in the data center, or it might be in AWS or Azure, Oracle Cloud, or SAP HEC, we run them through the same controls. Who are you? What do we know about your device? What do we know about the risk? Where are you going? But in this case, we only connect the user if they are authorized. And if they are not authorized, the resource is invisible. They do not see that the resource exists until they are permitted to get to the resource. And we do this by making an outbound connection from the user to the cloud. But we also make an outbound connection from the resource to the cloud. This is the second big revolution. And this is, instead of a VPN gateway at the edge of a network with an inbound listener that has to be in a DMZ, and it has to be clustered and load balanced. So you have the VPN, the load balancers, the DMZ firewalls, maybe global load balancing, maybe even denial of service protection, that stack of appliances. All of those functions move into the cloud. And we no longer have the inbound listener at all. Some idiot scanned the entire internet for vulnerable VPN gateways and published a list. You could say people should patch. I used to own patching the firewall VPN at Blue Cross. Don't say that to me. We had a change window once a month. We had 4 hours on a Sunday morning. All of our changes had to happen, and patches were the last thing on the list. If a change at midnight went wrong and they had to fix it and it took 3 hours, I didn't get to apply my patches. I'm sure they've changed that model now. The world is different. That was 20 years ago, but there will always be vulnerable servers. There will always be vulnerable gateways. We cannot make everything invulnerable. So let's not make it listen instead. Let's do away with the listener, make an outbound connection. That is the next big revolution. And the third big revolution is we want to only connect a user to an application and not connect an endpoint to a network. If you connect an endpoint to a network, if you connect an endpoint over a VPN, you must lock them out of everything you don't want them to see. With zero trust, instead, you can connect them only to the things that are authorized. That's not always easy, and you must know what those things are, but we can help to gather that information. So it means that we can prevent some of these compromises. If one user gets ransomware, there is no reason that every device around them should get ransomware. If an attacker gets into one server, there is no reason they should get to all the other servers. And we can also prevent data loss. So even if an attacker does successfully attack one user or one server, they cannot exfiltrate, they cannot take away the private data. So this is critical when you look at the alerts on firewalls and VPNs. If you have a firewall, there is a limit to what you can hide. The firewall is at the edge of the network. The VPN is waiting for a connection. You cannot hide them. Whereas if you have a zero trust solution in the cloud and you come out to the cloud, there is nothing to attack. So we can eliminate the external attack surface. Once the user gets access to an authorized resource, we can help you get to the point where they can't get to anything else. That takes time. It's not an easy problem, but we have tools to say, you may start by giving them the same access, the broad access they have today. If you do that, our tools will tell you who is accessing what. And then our tools will help you define the groups of users and the groups of applications to make more granular policy, a true zero trust policy. This will help you to prevent one small breach from turning into a large breach. And in fact, it will help you to prevent that first breach from ever happening. You can protect your users from ransomware. You can protect your data from unauthorized access. And this means that you can make sure that that data is secure and it stays where it belongs. Bank robbers rob banks because that's where the money is. Attackers target VPNs because that's where the connection is. If we take away that connection, then they will not have something to target. If it was that easy, everybody would be doing it. This idea has been around for a long time. It's been too hard for most of those years. It has not scaled. It has not been resilient. It has not been easy to make these lists of who gets to what. The Zero Trust Exchange is a secure service edge that is built on a zero trust architecture. So you use the WAN edge to bring a packet to the cloud. We don't care how you get it there. Could be SD-WAN, could be a router, could be a wired network or a wireless network or 5G. But you get the packet to the cloud. And we apply the zero trust principles to deliver these security functions. So we have inline inspection. We have the ability to do API-based integration. We can tie in visibility and analytics. All of your traffic comes through us. That gives you a very powerful tool for understanding where your traffic is going and making sure it's only approved traffic. So this is how Zscaler implements the secure service edge. And I will provide these slides to you afterwards. I know there's a lot of words on these slides and it's hard to read them all at once. This next slide is even worse, and I apologize. But Fundamentally, we are the most comprehensive, most mature zero trust architecture that exists today. We have a network of data centers around the world, over 150 data centers for a true multi-tenant environment. So we have high availability and high performance. On this network of data centers, we have a range of policy engines. Could be real-time threat protection, could be artificial intelligence and machine learning. We get 300 trillion signals a day, and we apply AI and ML to give comprehensive visibility and control. We have the outbound only access, so you can really take your attack surface dark, and we can apply these risk-based, context-based policies. All of this goes into the broad zero trust exchange to deliver zero trust security and connectivity. We do this for users, we do it for workloads, we even do it for IoT, Internet of Things, and other dumb devices. We've had many different validations of our theory here. Some of the most strict standards for security and control come from the US federal government. We are authorized to operate at FedRAMP High with ZPA. We have IRAP authorization, the equivalent for the Australian federal government, and some basic certifications like ISO 27001. Some of the most demanding standards in the world have been applied to our security products. When you think about how to deliver zero trust, though, it's not enough to just say, hey, we have a cloud, send your packets to our cloud. The architecture inside the cloud matters also. So 10 years ago, I worked at Juniper Networks. And if you said cloud to me, I said, go away, because we were running virtual appliances in AWS. As far as I could see, we were moving people's security problems to a rack that they could not reboot. Same security problem, different location. When you do it that way, you don't get a lot of advantage. Most traditional security vendors who made a cloud offering at the end of their product's life, they have based this cloud offering on the CDN model, the content delivery network. With a content delivery network, you have on-ramps everywhere. You cache the content at the edge, and you make a decision deeper in the cloud whether to give access to that content. There's a very small range of intelligence of compute nodes. There's a very broad range of these on-ramps. This works okay if it's content because it's all cached at the edge, but it is not good for security because every security decision has to go back to these small compute nodes. So if you are a next generation firewall vendor and you stand up a cloud, you may have hundreds of front doors, but you only have a handful of compute nodes. On the other hand, Zscaler was born in the cloud. We don't have a difference. Our edge nodes, they are also compute nodes, 150 of them. So every time you come to Zscaler, the policy is applied at the first point you touch. That makes us faster, more scalable, and more resilient. You don't have to go somewhere else in the cloud to get an access decision. So when you think about cloud native zero trust versus the legacy network security vendors who made a security cloud later, architecture matters. It's like comparing a regular car like I drive. I drive an old gasoline car. My car is from 2009. It runs just fine. But my best friend has a Tesla. We don't talk about how many cup holders we have. We both have the same number of cup holders. She has heated seats and I don't. That's fine. But the real difference is what is under the hood. Her car is faster, more sophisticated, more efficient under the hood. My car, it's an older car. It gets me where I need to go. The same thing is true with the cloud. You have to ask what is under the hood. This is another slide with too many words. Marketing sometimes does this. I could not figure out how to make it simpler, but we will share these. The operational excellence is also important. Maturity is a big deal. A mature company has a proven track record. We have over a dozen years of operating a security cloud that has grown based on customer demand. Some of our competitors started out as one product and then they acquired this and they acquired that and they added something on. So in their original product, they've got good deployment. But when you start to look at the full platform, not all the features are adopted, not all of the features are proven. And they may have limits in the platform itself. They have a challenge, perhaps, where the features do become a little more important. If you show me a car and it does not have cup holders, probably going to ask you where I can put my drink. So it matters what is under the hood, but we also want to consider the breadth of the offerings and the scalability of the service. Zscaler's single scan multi-access architecture means that we will always outperform a cobbled together solution where you take a packet and you go to this resource, you go to that service, you go to this service, we call it service chaining. Zscaler does not do that. We take a packet, we put it in memory, we run everything against it at once, and then we send it on its way. Our CEO says, there is no substitute for experience. There is no compression algorithm for experience. You can't take 12 years of experience and compress it into 4 years of running a cloud. We had to live through it. On top of all of the revolutions in the concepts of zero trust. So revolution 1, zero trust has to be outbound as well as inbound. Revolution 2, we want to eliminate that attack surface. And revolution 3, we want to connect a user to an app, not an endpoint to a network. But those are all ideas. We are also driving evolution in the implementation. So when you first think about Zscaler private access, Zscaler zero trust, we often start with a conversation about VPN replacement. How can you do remote access with no attack surface? How can you connect a user to an application, not a virtual private network? We can accelerate value for a number of use cases. These remote users can now come in without the risk and without the full range. You don't have to start that way, but you can get there eventually. And as the pandemic eases up, we're finally coming back to the office. We can extend these controls for users in the building, as well as users outside the building. We can address third-party or business-to-business, B2B, partners, vendors, suppliers, contractors. How do we give them access to one or two things, what they need to perform their service, without giving them access to everything? Or let's say that you have manufacturing or critical infrastructure or energy. You have Internet of Things, you have operational technology, can protect those environments as well. We also help with some business transitions. If you acquire a company, you've got to figure out, how do you give those users access to your resources? Do you integrate the two networks? That's complicated, it's expensive, and you're exposed to their security gaps. But if we can provide user to application access, you don't need to worry that you just acquired a breach. We can also accelerate and streamline app migration from the data center to the cloud. If I'm connecting a user to an application, it doesn't matter whether that app is in the data center or the cloud. The user doesn't even need to know the difference. You can have apps in the data center. You can have apps in AWS, in Azure, in Oracle, in SAP. You could have your own private cloud. The user never should know. Also, the services need to evolve. We started out applying zero trust for users, Zscaler internet access, Zscaler private access, protecting user traffic out, protecting user traffic in. But we're extending that to workloads. Maybe you have, again, OT or IoT, privileged remote access. Maybe you have servers that need to communicate securely across the different servers. And we're also adding new forms of protection. That could be ZPA inspection. It could be the new technology of active defense, deception within the network with honeypots. Remember honeypots? They've been around forever. Now we can deliver those from the cloud as well. We can confuse an attacker, we can distract them, and we can give you a warning that somebody's poking around in your network. So all of these new technologies, each one of them could be an entire talk on its own. And if you're interested, please reach out to our team and we'll be happy to talk with you about it. Zscaler, our zero trust exchange, is the modern way to do zero trust. We want to give you the confidence that you can tackle this difficult problem. I was, before coming to Zscaler, I was a global NAC specialist for 10 years with Juniper, and then when we got sold off as Pulse, I tried to do NAC for a decade. And in almost every project, we would get partway done, 60%, 80%, maybe even 90%, but that last bit was impossible. We didn't have the money or the resources or the technology or the willpower to get there. So you saw that NAC was monolithic, and you had to protect all of your network to really reduce your risk, but you couldn't actually get there. I am with Zscaler today because I got tired of that and I wanted a better answer. We are trying to change the way zero trust is done. We are trusted by some of the largest and most demanding companies in the world. We are leading the industry and we are revolutionizing the technology. We have operational excellence that enables us to deliver the services you need. Resilient, seamless access protection, full visibility for all of your users and all of your traffic. We have the most comprehensive approach to zero trust security. We're covering outbound and inbound traffic. We're covering all these use cases. We're covering users and workloads and critical resources. And we're doing this based on an architecture that's designed to scale, that is built to evolve. And we will continue to innovate and make new definitions for zero trust. This is the way that I think of zero trust. And I would encourage you, consider with this tool, what are the individual problems you could solve? But more importantly, what is the bigger picture of what you could do if security was an enabler of the business use case? If you were able to eliminate your attack surface externally, not have that risk, if you were able to enable local breakout, direct internet, and reduce that dependency on complicated, expensive direct connections. We have a number of resources, and somehow my slides have gotten messed up. Here we go. If you would like to learn more, we have an entire page on our website with resources about our Zero Trust Exchange. We have a webinar that we did recently on use cases for Zero Trust. But most importantly, we have our user conference coming up. And like this event, it will be both in person and virtual. It will be in June, and you can have conversations with other peers of yours who are executing this in their own companies. You can learn from our customers' stories. You can learn from our product experts. You can learn from practitioners. You can do training or attend keynotes or attend breakouts. We even have CXO roundtables if you're interested. So I encourage you, come to Zenith Live. Come in person, come remotely, but join us there. We will continue this conversation. I do have a brief demo, and I just wanted to check in with Yadira and Jorge. Do we have enough time, and can you hear me well enough for a demo?
Yes, can we hear you perfectly? Nice.
Okay.
So just okay. So I just want to make a little bit pause, Lisa, just to validate if everybody here has any doubt that we can address with you. Y ahorita estamos escuchando, o sea, una breve demo nada más validar con ustedes. Si alguien tiene alguna duda, pregunta sobre lo que estuvo platicando. Si quieres dar la repito para la audiencia. Filtrado web y todas las capacidades que teníamos adentro de una empresa o de una oficina, hoy ya no son tan útiles. ¿Por qué? Porque el usuario está viajando, el usuario se está moviendo, el usuario se está conectando a aplicaciones en la nube que ya 100% uno crédito, pero prácticamente teniéndola, pues ya puedo gastar, ¿no? Eso es lo que estábamos haciendo cuando damos accesos a la red. Le estamos dando las llaves del coche, la tarjeta de crédito a quien entra a la red. Y hoy vamos a cambiar el paradigma. Primero valido que eres quien dice ser, para después validar si tienes acceso al recurso que te estás pidiendo. Si no se cumplen esas dos condiciones, no te dejo. ¿No? Que justamente un slide de Lisa decía eso. Identidad, broker e intercambio, ¿no? ¿Quién eres? El broker que me encarga de conectarme y la validación para interrumpir la conexión si no eres ninguno de los que dices ser. Lisa, do you want to say something else? I'm sorry for switching to Spanish.
Community at a time, one resource group at a time. And eventually you have everyone migrated to the zero trust, and then you no longer need the network security controls. You can decommission them, you can save that money. So this is not a hard replacement. It is not rip it out and put something in. This is a gradual migration. And to illustrate that, I wanted to show you how simple the user experience can be. Jorge, are there any other questions before we do a quick demo?
Okay, Lisa, no, we are ready to go.
Great. Okay, so we will first start with the user experience. And in this case, I am using the Zscaler Zero Trust Exchange. I have the client connector. This is a lightweight agent that runs on my computer or on my phone, and it protects my access to private resources with private access. It protects my outbound access with Zscaler Internet access, and it shows the administrator information about my connections with Zscaler Digital Experience so that you can solve performance problems, you can protect the user on the internet, and you can control access to private resources. So I'm going to turn on Zscaler Private Access, and it has detected that I am off of the trusted network. I have authenticated to the system. It knows where I'm connecting. So now this is instead of a VPN. And so let's say that I need to get access to an RDP connection. This is a common use case where I need to RDP into a server. I may just use the short name of the server, and I'm going to connect here. This traffic is going over ZPA. The ZPA service is making sure that I am authorized. So terminate, authorize, and connect. I am now connected by RDP here, but I want to show you something interesting. If we look at my DNS, I went to server 01, and you can see that that is server 01 in safemarch.com. And I got an IP address of 164.1.1. This is only important because it allows me to illustrate a point. If we look at what I actually connected to, if we look for my traffic, we can come in here and see if I can find myself. I am connected to that backend server. And that backend server is actually on 192.168.1.10. So the real server is on a 192.168 address, but I don't see that. I see a 100.64 address. We are protecting the environment from the user. We are restricting the information the user sees. We are allowing the user to access only authorized resources. So I can RDP to this system, and it is based on the policy that allows it. We can see that I'm going through a connection that is in the AWS environment. We can see that I'm going through a broker in the Zscaler cloud that is very close to where I live. And we have a great amount of information about my connection. We can see everything you would see with an IPsec VPN: start and stop time, total bandwidth, total duration, the policy that permitted it. We can also see exactly what service I went to. Now you know what I did, and you can see how I got there. So private access gives a user experience that is exactly like being on the network. I start my RDP client, I type in a host name, it takes me there. It protects the backend environment from the user, it limits the amount of information the user can see, but it gives the administrator a rich set of information. One of the biggest challenges of zero trust is writing the policies. It's actually very rare to have enough information to say who is allowed to connect to what for every user and every resource. So when we write policies in ZPA, we have two ways of defining targets. We can define exact targets. We can define IP addresses. We can define specific host names. We can do more than one thing as a target, but internal subnets. If you define a specific application, you can say who is allowed to go to it. You could say every employee. You could say specific employees in this group. You could say employees in this group on a corporate device. When you define a wildcard, so now we found a server that I didn't know existed. We can see that people are using it for SSH. And I could write a user group for these users. And this is how you solve the hardest problem in zero trust. The hardest problem in zero trust is not actually controlling the traffic. And it's not actually delivering the traffic. It's defining who should connect to what. Many, many NAC solutions have failed because you had to figure out that answer. With Zscaler, we will help you figure out that answer. Is there a question from the group? Okay, so we provide a rich set of information about this environment, and it will help you understand what are your top applications, who are your top users, and what are they connecting to? So you can use this information to troubleshoot. Why is this user trying to go to a resource that they're not authorized for? There could be a number of answers. It could be the resource was added and nobody told the security team he needed access. Or it could be he's poking around with something he shouldn't be. But you can easily see policy blocks. You can see who is connected. You can see which users are making the most bandwidth, which users have the most applications. You can see the same thing for the apps. You can see the top errors, and you can also see what applications are the most popular. So we give you rich visibility into who is connecting in your network. And once you use that visibility to figure out who needs to connect to what, we also give you rich controls for what people are allowed to do. So this is a demo environment, and we were building a set of demos to say, we have different types of users. We have an administrator, we have a contractor, we have an employee on BYOD. So if you're an administrator and you're on an authorized device, we're going to allow you to go to a set of resources. But if you are on a non-authorized device, we're going to specifically block you so we can give you an error and say you need to be on an authorized device. If you're a contractor, we might let you go to a file share or a web app, but we're not going to let you RDP and be an administrator. And if you are a BYOD user, maybe they're on a personal device and it's not authorized, then maybe we're just going to give you web-based access. So there is a lot of information to help the administrator with visibility and with granular control. But at the end of the day, the user experience is very simple. I open a web browser. I type in a URL. If I could type, I'd be dangerous. And it comes up exactly as if I was on the network. They put a self-signed certificate on this, so I get a certificate error, but this is the problem with demo environments. It's a certificate error. But if I try to go to a resource that has a real certificate, let me see what we've got in that demo environment that's working. Nope, they must have certificate problems in the back end. I will say, though, that when the certificates work, when the resource itself works, Zscaler makes it very easy to get to it. So you can see that we can RDP. We can also carry things like a file share. We can even carry complicated applications like SAP that might be talking to more than one thing on the back end. And again, it is as simple as opening RDP, connecting to the server, opening the file manager, and connecting to the file share. If you are interested in exploring ZPA, it's very easy for us to help you set up a demo environment. But maybe you don't even want to try to go to a demo environment. Maybe you just want to kick the tires a little bit and see. We have a solution called ZPA Interactive. And ZPA Interactive allows you to have a free hosted demo experience. So if you search for ZPA Interactive, you can actually try it for 7 days. And you will see that Safe March environment. That is our demo environment. You can see a user experience. You can see an administrator experience, and we will make sure that the certificates are all in place for the web services. So I encourage you, first of all, if you would like to see what this looks like in more detail, to go to ZPA Interactive. And again, Zenith Live is going to be one of the best places to learn about ZPA, ZIA, and the Zero Trust Exchange in general. So we welcome you to join us at Zenith Live. Any other questions or anything else you would like to see about the administrator experience here? Well, I think that Jorge and Yadira had a quiz for you. And so if you'd like to continue the conversation, I would be happy to speak with you at some point in the future, but otherwise I will turn it back over to Jorge for the quiz. Thank you.
Vamos a bajar más alta.